Hello, everybody. So this is Justin, and my function I was given to take a derivative of is above here. I'm not going to try and spell it out. Rather than try and like whiteboard the answer to this, I'm going to do it right in this Lix editor that I use for a lot of my math work. And I'm going to kind of use it as an opportunity to give a mild tutorial in it, but nothing in depth. Just enough to kind of show that it's sort of a handy thing to know, and hopefully you'll see that as I walk through here, because there are times where I legitimately don't want to whiteboard something because it just requires so much copying and pasting, and I could do that on the computer, and I can't do it on the whiteboard. So here it goes. I'm just going to get into it by simply retyping the above function I've got there. So we go insert math display formula, gives me a nice centered big box that'll expand if things require it. So we just start typing L paren x paren equals x. Then we do a caret, shift 6 there, 3 for the squared. Space brings us out of that mode back down, and then we want to do a parenthesis here, but we want a big one. I want a kind of big one, so I do this weird BI double G thing. Gives me a big one. Backslash frac gives me a fraction, 4x caret squared. Go down arrow a couple times here, backslash frac, e to the x with a little caret there, a couple down arrows, 3x. Easy peasy. Arrow over to the right a little bit, nice big parenthesis again. And that's the hairy stuff is done. C dot, multiplication dot, cosine for the cosine function, paren, backslash sine for sine function. Kind of a pedantic difference. You can just type sine and cosine. I don't think most people are going to notice, but if I'm going to be teaching, I'll do it right, I guess. X caret to the fifth, space to bring us down, and close the two parens. Hit space and we're out of the math editor. Enter takes us to the next slide. Now all this is driven by LaTeX. If I hit view code pane preview with my mouse and the cursor in there, you'll see that LaTeX preview. And if you saw the email I shot to the class with this little blurb in here, that's exactly how I got it. If you notice the keystrokes I called out, I didn't deal with curly braces or that particular pedantic part of it. Basically, the timing of the space bar is what tells it when to go to the next section. And that makes it go an awful lot quicker. I'm kind of a programmer by nature, and I'm used to typing out goofball stuff like this, but even I tend to shy away from that and prefer the little front ends like Lix here. So as hairy as that is, you can break it down into a nice simple function. When you think about it, it's just really insert math display again here. L of x is equal to A of x, C dot O of x. That's fundamentally the nature of this one. And so if you know the product rule, should not have done a multi-line there. Just throw another one. L prime of x via the product rule is A prime of x times O of x plus, whoops, A of x times O prime of x, just like that. I mean, that's really all there is to it. Sticky wicket here is finding what A prime and O prime are, because A is that is A of x, and this cosine of sine of x cubed, or x to the fifth, is that's our O of x. And we just need to keep breaking these down further. Okay, so with that all established, we're going to keep breaking this down even further. So I'll just put some numbered formulas in here, make it easier to refer back to them. So A of x, we've already established, is this particular hunk right here. And we're just going to work on chopping away at that one for now. We'll leave O of x for later. It's a whole lot simpler problem. So A of x, when you really look at it, is like B of x times C of x, which is another product rule. And we can break that down to where B of x is equal to x to the third. That's just, this little piece on the left-hand side there. And then with that said, I'm just going to go back up and copy because that's the point of doing it this way. C of x is equal to that chunk. Well, what we're doing as we decompose this whole thing is we're looking for things that we can actually solve because they're just a simple polynomial or a power rule, exponent rule, something like that. So we can drop down. So here we already have an answer. B prime. Oh, that's embarrassing. B prime of x is 3x. We got that one through the power rule. And then we just sort of keep breaking this down if we want to keep going with that pattern where C prime of x, because this is a quotient thing going on here. Well, trying to define C prime of x wouldn't make any sense right now because we have to genericize or deconstruct C of x first. So that's actually looks like, we'll call it D of x over E of x. And that's just to illustrate that we've got a quotient rule going on. And so if C of x is equal to D of x over E of x, then C prime, we can find the quotient rule. Cop out here and just copy and paste that from a other version of this particular problem I've already gone through and get that definition. I'm gonna get rid of the LaTeX preview at this point, though. Don't really need that here. Gives us a little more real estate. So we can't find C prime of x until we know D prime and E prime because that's how the quotient rule works. So let's just keep breaking it down, spell it all out. D of x is 4x squared. And with that, we know that D prime of x is 8x. We use power rule and constant multiplier, combine them two down, get an 8x out of that. After that, we have E of x is, I was afraid of that. It's another quotient. So we got e to the x over 3x, which we're going to call equal to basically f of x over h of x. And this is why I started the second half of the equation out at O. We're using up a lot of it here. So with e of x obviously being a quotient rule type thing, then we know that e prime of x is going to fit that pattern. I copied and pasted that out of a different window again. So we'll break that down into f of x is equal to e of x. And h of x is equal to 3x. So those are pretty easy to find derivatives of. F prime of x, whoops, lost my cursor. F prime of x is equal to e of x again, because that's, exponent rule is basically natural log of e to the x. Natural log of e is 1, so it simplifies down into e to the x. And I made a mess. Okay. And h of x is 3x, so h prime is equal to 3. That one's fairly easy. Okay, so at this point we've basically deconstructed the entire left-hand side of that equation. So the a of x has been ripped apart, but we still have a couple of unknowns in that we haven't filled them in. And I kind of called them out as we filled it out with this e prime of x and c prime of x. Once we realized we needed them, we didn't actually have the answers. Sorry, I might have to edit that out. When we realized we needed them, we didn't have the answers to solve them until we drilled down further. But now we've defined everything under E prime and everything under C prime, so we can finally do that. And we're just going to start substituting stuff in. So we've got E prime of x is equal to the fraction of, let's see, f prime of x, which is just e to the x, times h of x, which is just 3x, minus f of x, which is just, again, e to the x, and that's times h prime of x, which is 3. So we'll just move that around 3x. Yeah, there we go. And 3x e to the x. That'll be a little bit cleaner because this is going to get copied and pasted around. And then we have hx squared. That's 3x squared. So we'll do a nice big square bracket. 3x big bracket squared. So that's e prime of x. We've defined that one now. Now, c prime of x is our next big one that we have to get taken care of. Insert another display formula. So c prime x is a nice big fraction of d prime of x. That guy is just 8x times e to the x, which is that chunk right there, you get x over 3x. We'll get there. There we go. That's minus d to the x, which is 4x squared. Whoops. C dot e prime, which is that handy little chunk right there. So there we go. And that's all over e to the x squared, which is e to the x. Here, copy that chunk there. And this is, now I remember why I've been using big parentheses, because this one kind of requires it. There. Now it's nice and tidy now. Now by now we're completely lost because I don't remember what problem we're actually trying to solve. And the reason we don't remember what problem we're trying to solve is I never stated it up above. We're trying to solve for a prime, and in this particular case, a prime of x is equal to, copy and paste from somewhere else, b prime of x plus, or times c of x plus b of x times c prime. So we've solved all of those pieces at this point, so now we're going to just plug them in. Insert math display, a prime of x is equal to, and now we just go hunting back for our notes. B prime is nice and easy. I don't really even need to copy that. 3x. Whoops. Times c of x. Let's find that one. That's a little bit hairier. Copy. And all that gets added to b of x, which that's just x to the third, right? Yep, x third. So we'll just x to the third prime, which is this handy little thing right here. Whoops. And then, just to keep it clean, I'll throw some nice big parentheses around that. I like big parentheses. I'm like the Bob Ross of parentheses. You just put a little bit here and there. It's all good. Happy parentheses. Okay. So that's A prime. Now, our original problem was like scrolling up here. A prime times O of X. Got those. Plus A of X. We got that. Now we just need O prime of X. And O of X is equal to this. So we're going to head back to the bottom of our document. Oops. And we'll say O of X is equal to that. Now we're going to start tearing that one apart. So to take this one apart, it's not nearly as hard. So we'll take a look at this one. Kind of jumps out right away as a chain rule at you. So we've got basically O of X is equal to P of Q of X type of deal, where P is your cosine and Q is your sine, and X is the X to the fifth, but we're not going to worry about that yet. So because it's a chain rule type deal, we know that O prime of X is going to be equal to P prime of, make a nice big parenthesis, happy parentheses, Q of X, closing big parenthesis, times Q, Q prime of X. So now that we've got that kind of dissected, we just start defining some new pieces here. P of X is really just cosine X, and oops, and we'll just throw in P prime of X because that's a nice simple one, is equal to the negative sine of X. Whoops. Good there. And then bugger all. Alright. Q of X is going to be equal to sine X to the fifth on that one. So at this point, we're to where O prime is what we need. We've got P prime right down here, negative sine X. We've got Q of X. That's right there, sine of X to the fifth. All we need is Q prime now, but we can't get Q prime until we do another chain rule. So Q prime of X is equal to the pause here. Sorry, I was getting ahead of myself there. So really, what we want to look at is Q of X is equal to what you could think of it as is R of F of X, and that gives us a chain rule. Whoops. And that means that, and I'm going to copy and paste here because this is getting quite lengthy. It means Q prime of X is R prime of F of X, yada, 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 right? And in this particular case, we know that R of of x is sine of x, because that's the inner portion of, well, getting off track here. R of x is sine of x, because that's the outer portion of q of x, and then the inner portion, which we'll call s of x, is x to the fifth. And getting derivatives of r and s are fairly trivial, because we know that r prime of x is equal to cosine of x, and an s prime of x is simply going to 5x to the fourth. So that one's nice and easy. Now we're finally to a point where we've drilled down far enough that we can define our O prime of x, which we had originally indicated up here would be P prime QX, QX, or Q prime X. So we have P prime X is negative sine, oh, come on. Negative sine of QX is sine x to the fifth times Q prime, which is R prime. Boy, this thing nests pretty deep. So what we're looking at here is O prime has to have Q prime in it. Q prime is this thing, and that thing is R prime, which is cosine of x cosine of x to the fifth times s prime is 5x to the fourth. So that gives us O prime. Now, if we wander way back up to the top, where our original problem is we need this. So we can take that all the way down to the bottom. Insert math display, drop that in here. So now we can do happy fun time, copy, replace. O prime is this thing. That goes in there. And now we need A of x, O of x, and A prime. A prime is the big monster we had right there. That's A prime. Happy fun time. There you go. O of x. That's an easy one. O of x is just this right-hand side, the original one. There we go. Down to the bottom, O of x is that. A of x is also the original left-hand side of this thing. There we go. Copy, paste. Happy parentheses. There we go. So it doesn't actually fit all in one line anymore. But that is your eventual solution to L prime of x for the original equation. It's not too hard once you get into the pattern of it. You're just breaking things down until you can find the derivative of the simple polynomial, or whatever you want to call that particular chunk. But yeah, there's really just divide and conquer. That's all there is to it, guys.